In this lecture, we look at function inverses. In an earlier lesson, we introduced functions by assigning U.S. citizens a Social Security number, or by assigning students and staff at Sam Houston State University a student ID, often called the SAM ID. The function SAMID assigned to each student or staff a 9-digit number that begins with 3 zeros. The SAMID of the author of these notes is 000354765. So if you plug in Ken W. Smith into the SAMID function, you get out this 9-digit number. In practice, it is important not only that the SAMID be a function, but that the function process can be reversed. Computer databases at Sam Houston allow a staff member to type in the SAMID and pull up information about the student or staff member associated with that SAMID. Each SAMID number is linked to a unique student or staff member. This is the concept of an inverse function. If SAMID as a function maps student or staff to numbers, the inverse function, SAMID inverse, maps numbers to student or staff. So, for example, the inverse function of SAMID will take the 9-digit number 000354765 and map it to Ken Smith. In many applications, we need to reverse the function process, asking for the input x that was associated with an output y. Look at the picture below. Given a function f of x with inputs x from the left and outputs y on the right, we would like to reverse the process, taking outputs y on the right and restoring the original input x to create the inverse function. If f maps from capital X on the left to capital Y on the right, then f inverse would map from capital Y on the right to capital X on the left. In the picture above, we have a function f from x to y. We want to create an inverse function from y to x. We write f superscript minus 1 for the new function that reverses this process. Note the superscript minus 1 does not mean reciprocal. F inverse is not the reciprocal of f of x. It's not 1 over f. The notation can be confusing. Don't confuse f to the minus 1 with the reciprocal. Here's something from Wikipedia. Suppose my function f maps ABC to 1, 2, 3 as described in this first picture. Then f inverse reverses the process, and that's in the second picture. If a goes to 3 and b goes to 1 for the function f, then 1 goes to b, 2 goes to c, and 3 goes to a in the inverse function. Again, reminder, the superscript minus 1 indicates the inverse function. Not every function has an inverse. We'll look at some examples of functions where we can reverse the process, and then we'll look at some examples where we can't. For example, let's let f of x be 3x plus 5. We can write this function in the form y equals 3x plus 5, and suppose we're given a particular output y. Can we recover x? Yes. Let's take the equation y equals 3x plus 5 and solve for x. Y equals 3x plus 5 implies that y minus 5 is 3x, implies that y minus 5 over 3 is equal to x. We've solved for x. We've discovered that if we're given a particular y, then x is y minus 5 over 3. So the inverse function, g of y, is y minus 5 over 3. We will follow custom in this class and use x for inputs and y for outputs. So once we find this inverse function, we'll say that in fact g of x is x minus 5 over 3, or the inverse function is x minus 5 over 3. Suppose f of x is equal to x squared, where my domain is the real numbers and the codomain is the real numbers. If we write y equals x squared and we're given a particular value of y, say y equals 25, can we reverse the process and find x? If y is 25 and it's the square of something, what did we square? In this case, we can't necessarily reverse the process, for both x equals minus 5 and x equals 5 are mapped by this function to y equals 25. There are two different inputs in the function f of x equals x squared that are both mapped to 25, so we cannot reverse the process in a unique way. The function f of x equals x squared, with domain all the real numbers, does not have an inverse function. Occasionally, though, if a function does not have an inverse, we may be able to change the domain of the function so that on this new domain the function is invertible. We can do that in the last example. We could change our original function so that the domain of the original function is the interval from 0 to infinity, the non-negative numbers, instead of just the whole real line. If we agree that no negative numbers are to be put into this function, then the ambiguity about x goes away. If y equals 25, and I say we're only plugging in non-negative numbers, then you know that x must be equal to 5, not minus 5. In this case, if I restrict my function f of x equals x squared to the interval from 0 to infinity, when I define it, then the inverse function is just the square root function. In the next presentation, we will practice inverting functions.